Hello everyone and welcome to this interesting session on data modeling in MongoDB. So we'll start off this session with different concepts of data modeling, and then we'll discuss the different types of data modeling, namely the flat, the star schema, relational model, hierarchical model, the network model, object-oriented model, and so on. And moving forward, we'll discuss the challenges faced while designing data model in MongoDB. And finally, we'll end this session by applying all of these knowledge in a real-life use case scenario. So today we have a special guest, Murli, who will take this session forward. So over to you, Murli.
Good morning, everyone. Welcome to Edureka. Welcome to MongoDB Certification Training. So the objectives are very clear. The first thing we are going to do is describe different concepts of data modeling in MongoDB. What are the various concepts you have? Right away, we don't go into the data modeling, but before that, we'll see what are the various generic data modeling techniques available outside your market and how these modeling techniques will be adopted in MongoDB. These two we are going to discuss first. Later, we'll see what are the actual types of data modelings that are available in MongoDB. We also see what are the challenges of designing your database modeling in MongoDB, and at last we'll see and we'll try to apply this in the real world use case. Introduction to your database modeling. We need to discuss about what are the basic building blocks for your MongoDB. So not only for MongoDB, for any language or for any database, we should understand what is your basic building block. So the basic building block for your MongoDB is nothing but a collection. So we come from the higher hierarchy to the lower hierarchy. Let's start with a server. I have a server. This server I am using to store the data. So the data that I'm storing here is nothing but a database. A database is the one which will be having multiple collections. So collection is nothing but it is a repository for storing all your documents. So what is the basic building block here? The lowest part, or if I come in the reverse way, if I consider this as a pyramid, the bottommost part of the pyramid is nothing but your documents. So we need to understand this document a little, what exactly this document is. So we know that document is nothing but a JSON, or we can call it as binary form of a JSON that is nothing but BSON. So we understand that a server is the one which will be store all your databases. A database is the one which will be having all the tables. The tables in MongoDB can be referred as the collections. A collection is the one which will be having bunch of documents. So a document is the basic building block for your MongoDB. What exactly the document is? A document is the one which is not of a PDF or not of a Excel or something, but it is nothing but your JSON. Or in other words, I can say that it is nothing but the binary form of the JSON. Now, what is this JSON is all about and what we are going to store? In a simple way, a JSON is the one which can be used in MongoDB for data interchanging. I have a server and I have an application. If I want to store some data into the database, which is part of my server, or if I want to retrieve the data from the database, all I need to do is I need some interacting medium. That interacting medium is nothing but the JSON. Why only JSON? Are there any other interactive mediums? Yes, we do have. So we have XMLs. Before your JSON and all, XML is the one which will be used for all your data interchanging purpose. But here XML is bulky in nature. That is, the amount of space it will occupy for the same data that will be stored in your JSON will be very, very high when it comes to the XML. So that is the reason we can say that JSON is a lightweight data interchangeable device or lightweight data interchangeable modules. And second, XMLs are difficult to read, not by the machine, but by the humans. It won't mind whether you're supplying a JSON or you're going to supply XML. But when it comes to the human, because we are the one we are actually designing this particular one, the XML, that markup language itself, a little difficult to understand. Everyone cannot understand that until and unless you have a good exposure to the XML. So what we should do? I need to look for a simple, lightweight, interchangeable medium, which is easy to read. Last but not the least, it should be able to carry most of the data types that is available for us. That is, if you want to store the data in an array, it should support. If you want to store the data into your embedded document, it should support. If you want to store the data into int32 or double or float or anything, whatever the data formats that are available to you, If the medium that I'm selecting is able to support all those formats or all those data types, then obviously I have selected the right one. So JSON is the one which will support almost all the data types to you. At the same time, it is a lightweight data interchangeable medium. So that is the reason we have selected the JSON. Whatever you can see on the screen, that is nothing but the basic format of your JSON. So now we're actually entering into your database modeling. So we are all using relational database management system, irrespective of whether we are a developer or administrator. Either you pull the data from the database, or you'll upload the data from the database, or you maintain the database itself. So having said that, you all have seen how a database works, or at least we all know that how a table is going to be. In RDBMS, irrespective of whether it is a DB2, or it is going to be RCL, or it is going to be MS SQL, or it is going to be Postgre, or it is going to be Sybase, or anything, take any database of your choice, irrespective of whatever the database you have picked. The first thing you can understand is these are the things we are going to follow or we use your data. That is, first, we create a table. It's nothing but we actually defining a table structure. Is you'll say that create table and you'll give the table name, followed by you also mention about what and all the variables that are part of your table, and you also define the metadata of it. It is nothing but this is my table. In this particular case, the table is going to have 20 variables, that is nothing but 20 columns. You also define each column length and also define each column type. If you want to create a table, this is the first step we are going to follow. So I'll create a table only with the physical structure, nothing but only the skeleton is available. Once the skeleton ready, then we'll go with inserting the data into that. So whatever the columns you have defined here, for all those columns, you actually insert the data. So when it comes to inserting the data, it is mandatory to insert the data into all the fields. When it comes to the RDBMS, irrespective of whatever the database you are using, it is mandatory that whatever the table structure you have defined, according to the table structure, you should insert the data for all the variables. That's nothing but if I have 20 columns, I have to insert the data into 20 columns. Out of that, I need to maintain the constraints information as well. If I have a primary key, the primary key should not be null. It should not be having the duplicates. Suppose if I'm going with your numeric data, I should not enter any characters there. I should not enter any special characters rather than your plus, minus, and comma. All these constraints I should follow while inserting the data. This is the main task. What will be the case if I have 20 columns, that is nothing but column 1 to column 20, but I'm not inserting the data into 5 columns. That is only for the 15 columns I have inserted the data. For the remaining 5 columns, I have not inserted any data. That is, I have not defined the data null also. I haven't defined anything, simply I left it. Will the system accept? The first answer for this particular one will be system will not accept. This we can call it as the schema. That is, once you define the table structure with the proper links and with the proper type, that will be called it as a schema. Whatever the data you are inserting into that particular table, it should be following your schema. And when it comes to the RDBMS, irrespective of whatever the database type you are using there, RDBMS is going to follow a very strict database modeling or very strict data modeling. Or I can say that it is going to have a strict and fixed schema. That is, once the schema is designed and whatever the data you are inserting into the RDBMS, you should follow the schema. That is, if you mention 20 columns, you should fill the 20 columns data. If you don't have the data with you, enter the null or enter the valid constraint, it will accept. But you're not supposed to leave any data. That is the first thing. Second, if I have 200 rows here, all the 200 rows must have the same 15 columns. I'm giving the 15 number here. That's the reason I'm going with that. whatever the columns I have here, all the rows in the table must have the same column. The first two fields, for an understanding, I'm just giving you an example. 101, 23, ABC. 102, 25, DEF. When it comes to the third record, if I want to enter like this particular person don't want to show his identity with the name, but he want to show his identity with his social security number or with his passport number. In that particular case, let's say if I want to give like this 103 and some age to this particular person 24, and at last, instead of giving the name, I would like to give some social security number of this particular person. Let's say SSN something like 705678, and if this is the number I would like to enter here, the system will not accept. If we enter any number like this, the system will still understand that whatever the string that particular user has taken, that particular user is nothing but a name only. He will not understand that as your social security number, because I have defined the third field as a name, and if I define the third field name as a string, as long as it is a string, it will identify that as a name. Though it is a social security number, from your case, the system will not be able to understand that as a social security number. Suppose if I want to enter the social security number, what is the case now? I have to make this as a blank. Then I have to enter one more field here as the social security number. Then I have to enter for all the users where the social security number is available. There I will enter, and for the users where the social security number is not available, store them as the blank space values. So everything, whatever the data inserts I want to do here, I have to do as per the schema. I should define the schema, then only I can insert the data into the schema. So all I mean to say here is, in RDBMS, I always follow a strict and fixed schema to store your data. Let's understand that whatever the table you have here, let's say this entire table is actually a student table, and obviously the student table is going to have a class teacher. Let's say we have a class teacher as well, and all these people, let's say I have a 60 students here, and all the 60 students are handling by only one class teacher, and let's say that the class teacher name is XYZ. Let's say this is actually occupying 8 bytes of data. I'm just giving you an example. I have 10,000 rows. So what is happening here? For 10,000 rows, I'm duplicating the class teacher name. Obviously, the first problem is going to be the data duplication. The second problem is going to be, that is 10,000 into 8, nothing but 80,000 bytes of the data I'm actually wasting, because we are unnecessarily storing the same 8 bytes information 10,000 times. So obviously what will happen? My data storage requirement will be always creeping up. It will be always going up. So how should I avoid it? When the people face this particular problem, they have come up with a new model, or they have come up with a technique called normalization. The normalization is all about trying to split the data into multiple tables by avoiding the redundant data. We'll try to reduce as much data as possible, that for the data redundancy. That is, the same table, if I want to express it after my data normalization, then it is going to be like this. I'll be having the ID and the following three fields, followed by, I'm also going to create one more table, and this table I don't create with all the values, but I'm going to create only with the required values. That is nothing but, here is the student ID. For the student ID, let's say all of them are belongs to the same class. So the class name, I'm going to take it here. Let's say all of them are belongs to a class called MongoDB, and all these guys are going to have only one class teacher, and his name is nothing but the XYZ. So what is going to happen now? Since I have a table like this, only 8 bytes of information for storing this, another 8 bytes of information for storing this. But how I'm going to match these two? I'm going to match these two based on their class. The common variable between these two is going to be the class, and based on the class variable, I'm going to join the tables and I'm going to get the required data. So RDBMS is going to follow the strict schema and fixed schema. Because of that, it is mandatory to maintain the schema, and according to the schema only I should enter the data. First thing, if I go with that, I may end up with a data redundancy. To avoid the data redundancy, we don't maintain a single table. Instead of maintaining the single table, we will go with the multiple tables, or we also call it as the data distribution. Technically, we can call it as the normalization. Normalization primarily done for reducing the data redundancy. So whenever I have a requirement, I simply combine the data by joining the tables, and I can populate the data to the users. Now actually enter into your MongoDB. Unlike the relational model, take any relational database where you must declare a table structure. Collection does not enforce a certain structure for a document. So two contradictory things. What is that? This is your RDBMS. RDBMS will allow you to insert the data only if you define a table structure, and only if you are satisfying the schema, or if you are inserting the data as per the schema, then only it will accept. But when it comes to your MongoDB, it is not like your relational database model, where in relational database model, where you define a table structure, then only insert the data. But here, a collection does not need that kind of stuff. You don't need to define your collection metadata at all. You don't need to mention what kind of data you're inserting there. It is absolutely possible that a collection can contain a documents with completely different data structures. So here in your previous case, we understand that if I have 200 rows and if I define with the 20 columns, it must be having the same 20 columns for all the 200 rows. But when it comes to your non-relational, that is nothing but your MongoDB, suppose if this is going to be my document, in this particular case, now you can understand that the first one, ID, username, age, friends, active, and gender. These are the key values I have here. Now, let's say that this is going to be a collection of a person. Simply, I can call it as a person table. In the persons table, first document is going to be this one. Now, I'm going with the second row of the same collection, and it is going to be like this. If you have a close look on it, both of them are having ID. Both of them are having username as well as the age. Both of them also have the active and gender. So that is nothing but I'm going to highlight only the fields that are not part of any of this document. That is, if I look into the first one, this particular field is not present in the second document. Let's take this example. I have name and SSN. While explaining your RDBMS, I have mentioned that one person wants to share his identity with the name, whereas the other person wants to share his identity with the help of the social security number. But he don't want to give his name, so I don't want name to be populated there. He don't want to mention SSN, so the SSN should not be populated there. Once again, when it comes to the RDBMS, it is absolutely mandatory that all the rows that are present within the table should have the same data structure, should have the same schema. But when it comes to the MongoDB, that is not the case. You can have absolutely a completely irrelevant data in the same structure. For an example, for a person's collection, one person wants to share his friend's information, but he don't want to share his eye color. Whereas the second person, he is absolutely okay to share the eye color, but he is not interested to share his friend's details. But both of them belongs to a person's collection, and I can see that both of them are having the different data structures. The schema here is different from the schema that is present in the second collection. But both of them are present in the same collection. It is absolutely possible in any non-relational databases. All I want to say is this one. Let's say this is a loan collection, but all of a sudden I store some irrelevant data here. Name, Murali, and class, MongoDB. Ideally, where I should store this data? I should store this particular data in a different collection that might be the collection of a teacher, or that might be the collection of an instructor. So there should be an instructor's collection. In the instructor collection, I should enter this particular detail. But what I have did, instead of storing the data there, I simply taken that and I dumped in the loan collection, which is absolutely possible. No harm at all. We know that it is difficult to maintain this particular data. We know that it is difficult to understand where the data is present. But what I'm trying to say is, in a hypothetical situation, you don't need to have any relation between the documents that is present within the MongoDB collection. The same collection can have completely irrelevant data structures. The same collection can have irrelevant data within it. It doesn't mean that all the data that is present in a collection need not to have the same structure. I don't need to define anything. Without defining anything, I can insert any data of my wish. If I come to the person's collection, in the person's collection, the second record does not have your friends, whereas the first record does not have your eye color. But both of them are valid and both of them are correct. RDBMS is going to have a fixed schema. I need to define the schema, and based on the schema only I can proceed. Whereas when it comes to your NoSQL, it doesn't follow any fixed schema. They only follow dynamic schema. Few books refer them as a no schema, but no schema is not going to be the right term. They still follow the schema, but not the fixed schema. They still have some structure and all. So that's the reason you should not call it as a no schema, but you can prefer to have that as a dynamic schema. Whereas RDBMS have a fixed schema. So the reason behind talking about documents a lot here is mentioned here. In MongoDB, all the interactions with the MongoDB are made through these documents only. In the CRUD operations, if I want to insert the data, yeah, send it by JSON. If I want to fetch the data, fetch by JSON. If you want to drop the data, you use your JSON. Suppose if I want to go with creating the collection is fine, but except that, suppose in the case where I want to insert some data into an employee collection. So what we did, so we simply say that db.emp.insert of, and within the insert, we simply mentioned JSON. Whatever you can see in the braces is always going to mention your JSON. So what he did, the employee table has come up with a JSON. The insert has done with the help of the JSON. I want to read the data conditionally. Is from the employee table only. Instead of inserting the data, just figure out all the male employee data. Whatever the condition I would like to pass, the condition itself I passed as a JSON. So let's say all the people, all the male employees whose age is more than dollar, I'm pressing wrong, whose age is greater than or equal to, let's say 35. I would like to fetch all the people's records where a person must be older than 35 years and he must be a male. I want to find this. What I did here, I simply passed a document. I want to drop something, I want to update something, or I want to upset something. Whatever I want to do here in MongoDB, all the interactions are doing only with the help of a document. The document is nothing but a JSON. That is the primary reason why we are talking about the documents here. Besides your storing your data, what else we can do? Define what data can be read, write, or update into the queries. That is nothing but the CRUD operations. Second, define which fields will be updated, data modeling with MongoDB. So what fields I need to update with the help of the data modeling? Creating the indexes. I have a replication and sharding. Entire replication and the sharding can be done only with the help of a JSON. Last but not the least, whatever the information I want to query from the database, no other option, simply depend on your database. Whatever I want to do within my MongoDB, that can be done only with the help of a document. The document is the key structure here. So we need to understand what are the basic characteristics of the document. These are not going to be the final things, but these three are the mandatory things. That is, every document that is present in MongoDB should follow or should possess these three characteristics. The first, the size of the document, very important. As I mentioned before, in the earlier versions of your 3.0, prior to 3.0, the maximum size of the document that will be allowed within the MongoDB is just 4 MB. But post 3.0, MongoDB has been changed this particular value, and the current size of the document is going to be 16 MB. What will be the case if I want to go with more than 16 MB? MongoDB still store them, but not like a single document. Instead, it will store as a file. We can call that as the Mongo files. Mongo files is itself is a separate binary that will be primarily used for storing the data which is having beyond 16 MB of the size. For an example, audio files, your video files, or of the images, wherever the size of the document is more than 16 MB, there and all, I must go ahead with your document size. That is your Mongo files. Lesser than 16 MB, store it as a document. More than 16 MB, using of Mongo files binary itself, we call it as the grid FS. So grid FS is nothing but if any document is having the size more than 16 MB, that can be treated as your grid FS. The first one is document size. Mandatory size will be you should not exceed 16 MB. If anything more than 16 MB, that can be done by using the grid FS. Why we should have restricted the size to 16 MB? The reason behind setting up this particular one will be through the blocks we understand that why they fix the size of the document to 16 MB means they measure the performance of your MongoDB storage, because MongoDB is an in-memory storage. That is nothing but first the document will enter into the RAM. Through the RAM only it is going to enter into your ROM. The RAM is the first one which is actually doing all your indexes and everything. So they measure the performance by simply increasing the size of your document from 4 MB to 6 to 8 like that. When they play with the size of the particular document, when they want to move from 4 MB to the new value, they understood that at a value of 16 MB, the IO performance through the RAM is at a really high rate compared to any other value. So that is the reason they restricted the size of the document to 16 MB. I'll go with the second one, that is nothing but names and values for the field in a document. Gender, age, this can be called as a name or nothing but a field. So what are the characteristics? The first characteristic will be your name should not have a dot notation. First dot name is an invalid name. Suppose if I want to enter any first name of a person like this, simply I want to enter like this, and I want to enter the other one. This is completely invalid. Why? Because my name is having a dot notation there. My field is having the dot notation. It is absolutely a wrong thing. So how can I insert the data here? If I want to insert this kind of data, I should go with a different data structures rather than simple key value pair. And the different data structure is like this. Mention it as a name. After mention it as a name, while entering your value, name is going to be the key. While entering the value, enter the names like this. Now you can see the difference. The document remains to be the same, but what is changing here? The one which is changing here is I mentioned the key as the name. Within the key, instead of going for the two individual key value pair, I'll go with the one key value pair where the value itself is going to be a document. So now, if I want to refer this, if I want to run this, if I want to fetch this particular data, there I'll use a dot notation. db.emp.find. Within the find, I should give my query, right? So what query I want to fetch here? I want to know all the people where the first name is Murali. But how to enter the first name here? In this particular case, I'll enter the first name like name dot first. Now you can ask me, Murali, you said that it is going to be wrong. I should not have a dot notation in the name. But you are using the same now, right? While inserting the data, the key should not have any dot notation. So this is the key, but here it is the key, and it is the key, and it is the key. While calling that particular key value, there I can use the dot notation. So here the first is nothing but name dot first. Here the last is nothing but name dot last. That is the first key dot subfield dot. If I have one more field within the first, let's say the first also I have created as a document. If I want to refer the lower here, how I can refer the lower? I can refer the lower like name dot first dot lower. I want to refer the higher. How can I refer the higher? Name dot first dot higher. So this is the place where I use the dot notation, but I will not use dot notation by giving the key parameters in your document. But one thing you need to understand here is The moment you use a dot notation, the system need to understand that it is a dot notation and you are actually representing a name. To make sure that you are able to understand this and you are conveying this to the system, you need to do one thing. That is, key value pair dot notation name must be in the double quotes or must be in the quotes. It always encode either it is a single quote or a double quote. But if you are using a single quote in the beginning, you should use the single quote at the ending as well. Then only it is valid. The second thing, whatever the name you are using here, the name should not contain a special character called dollar. Why? In MongoDB, anything that comes with a dollar is nothing but an operator. We use dollar followed by whatever the operator that you use. So your dollar is going to represent a operator. Whenever you use dollar in your name of your key, obviously it will consider that as an operator and it will never consider that as your key value. For an example, suppose if I want to give the first name, first underscore name, this is the general most of the time. Instead of using the underscore, I want to represent this one with first dollar name. And MongoDB understand that dollar name is an operator. Such kind of operator is not available, so it is going to throw you an error. Possible? Sure. This is the third thing. That is, your document should not have beyond 16 MB. Your document should not have the dot notation as the key values. So you're using the fields and the values, right? The maximum value of the field should not exceed 1024 bytes. That is, each individual key value pairs that we are entering, the key value pair should not exceed beyond 1024 bytes. That is nothing but the 1 MB. So where can I find all these limitations? We go with docs.mongodb.com. Just go to the server. As usual, every time we go to the server only. Once you go to the server and if you scroll down a little, there is something called reference. Click on the reference. Under the reference, you can see something called MongoDB limits and thresholds. The moment you click on it, you can see all the limits and thresholds. So whatever you are talking now we are talking about the Bs and documents. That is about the size. The second thing is naming restrictions. On the naming restrictions, now it is telling that it is case sensitive. You should not have any of these following things. It can be empty string, but it should not contain the dollar. It should not begin with a dot. It should not begin with system dot. And the maximum bytes, every piece of information is going to be available here. So this is not only for the data modeling, this is for the entire MongoDB. That is, for every place, wherever I have the reference, in that particular reference, what has changed and why it has changed and when it has changed. Every details has been given here. So all you need to do is go to your docs.mongodb.com, go to your server. Under the server, go for your references. Under the references, you can see MongoDB thresholds and limits. We'll go with the document one more time. And the last one is going to be the document primary key. So unlike a relational database management system, you don't have a proper underscore ID key here. Ideally, you should not have. Since we are coming from the RDBMS background, whatever the default field that is available in MongoDB, that is, the default field is nothing but the underscore ID field, right? The default underscore ID field that is present in the MongoDB will be referred as a primary key. But is it standardized or is it as per the document? Absolutely not. This is our assumption. And if I come to the properties of it, if you define well and good, if you don't define it, MongoDB itself is going to create a underscore ID for it, and it is going to be an object ID. It is going to be object ID, which is in a hexadecimal format. It is going to accept all the data formats except arrays, because array is not going to be the unique one, right? Array is the one, same field will be having bunch of values. So except array, any other document it is going to accept. If I come to the properties of it, it should not be a null. It should not leave it as a blank. And the last but not the least, it will not allow any of the duplicates. Only these three things, and these are nothing but your regular things. Let's say I don't want MongoDB to create the object ID. Let me create one small database. Let's say start in the background. I would like to start daemon server hyphen MongoDB hyphen DB path. I have a data folder here hyphen log path. I have the logs folder here. That log path is going to be a file, so I need to give the file there. Done, connected. Now let's see, are there any databases that are available? Yes, it is available. Here, the object ID has been created by the system. There is nothing wrong in that, but I want to take a control. That is, let's say every time I'm creating the object ID, I want to create it on my own. Let me go with the simple numbers of 1, 2, 3, 4, 5. Then it is handy for me. Instead of looking the data like this, I want to go in that way. But I want to make sure that it should be not having any duplicates. So what I should do now? So in this particular case, I can generate this underscore IDs dynamically by writing some Java code. And I can make sure that whatever the data that is I'm sending here are the underscore ID values, I can make it as a dynamic. So how dynamic is, if it is the first record, it will consider that there are no records available. So let me start with 1. If the new record is getting inserted, increment the value of I to 1. If a new record is deleting, if already existing record is deleting, it should update the deleted value as well. If I'm able to maintain such kind of things, it will be easy or not? So to mention your underscore ID or to generate your underscore ID, there are some procedures. You can go to the Google and you can find out it. But still, if you want to need it, here it is. This is one of the simple scripts that I use as part of my work. That's the reason I just simply tweaked it because I should not give the real data. So I simply tweaked it and I just used it. So whenever there is a new insert term for the user ID, automatically it will check what is the previous value of your underscore ID. From there, it is going to kickstart it. For an example, so now I'm just going with the new database. Within the new database, I would like to show you about this support collection. So for this, what I'm doing is simply, I just started with one of the function. Here is the function and inserted is 1. Then I started using a new function, which is called create a next sequence. It all is going to do is it is going to create a next sequence. So then I'm going with the find next sequence where I'm just using a keyword called retention. Under the retention, I'm just telling counters dot find and modify. From the counter, I'm fetching this particular data. I'm querying on underscore ID. I'm incrementing the value of sequence by 1. New value I'm taking and I'm returning it. It's supposed to do is since the counter has 1, it always needs to start with 1 value. Let's move to the next topic, that is what is called your challenges in database modeling. So this is the main reason where we actually go for the various data modelings that are present in the MongoDB. So the key challenges in data modeling in MongoDB are, first thing, balancing the needs of the application. That is it more read specific database or it is more write specific database? If you go for your read specific databases, let's say your apps, if you go for any news apps or if you go for any of the portals, the editor is going to send some content into your app. Once your editor is done, there are going to be more people who are interested to read your news. They are interested to read your cover stories. The write operations are less, but the read operations are really, really high. Let's go to the example of Facebook. It is combination of both. Some users will be only interested in going through the walls, but they are not interested to upload anything. But few people are very eager and they always want to post something on their wall. So it is the case where I have both the read as well as the write operations. You should know whether your application is demanding more of read operations or your application is demanding more of write operations. Next thing, I need to know the performance characteristics of the database engine. What kind of database engines I'm using? Am I using mmap even? Am I using White Tiger? Am I using in-memory or anything? So what are the advantages and disadvantages of them? The last one, we should know what is the data retrieval pattern. On what variables we are retrieving the data, based on that we are going to enable the indexes. So for that we should know the data retrieval patterns. If I know all these three, it is quite easy for me to actually enter into my safer zone or avoid all the hurdles in your database modeling. So here is the place we actually start with more demanding database modeling. MongoDB offers only 2 types of data modelings. First one, embedded data modeling. Second thing is going to be reference or linked data modeling. Embedded data modeling is the one. This is going to be the most commonly used database modeling when it comes to the MongoDB. What it is going to be is, let's say any student is there, we all come from our colleges or schools. So I'm just taking that example here. So what is the general procedure? First, we go to the admin. In the administration, you complete your registration work. So there you entitled with ID, your class, your personal details like your phone, address, or something. Then you enter into your class. Once you go to your class, again in the class you will be enrolled with the same student ID. Class remains to be the same. Here you entitled with which section you belong to. Then you are also going to get some information about who is your class teacher and what are the various semester it belongs to and what are the various subjects you need to undergone in this particular semester. This you are going to get. Then you go to the exam cell. In the exam cell, for the same student, for the same semester, what are the various exams he appeared, that is various subjects that he appeared, and what is the results of it. So generally how we are going to maintain, see, we are not going to maintain a single table for all these three departments. Instead, what we are going to do is we are going to have one table for administration, one table for class, and one table for the exam. So we are not going to maintain a single table for all this. Instead, we are going to keep this data into three different tables. And whenever someone asks, we are going to combine all these three tables and we are going to get the data. Now, when it comes to the MongoDB, we have two different patterns for storing this data. Pattern number one, that is model number one. Don't maintain individual collections at all. Keep everything in a single collection, but go for different data types. For an example, student ID remains to be the one, but the student ID repeated here, here, here. Class ID repeated here, here, as well as here. Semester repeated here or here. So instead of doing this, what your MongoDB embedded model suggests you is, don't go for multiple things. Instead, go for a single document. Let's say go with the student ID first, give the value to it, and just put a comma there. Then second thing, you're going to have a class. Third thing, you're going to have a phone and address. These four actually belong to your admin. And when it comes to the class, you're going to get only one new thing, that is called section. Just add it. And when it comes to the subject, let's say that you're going to appear for 6 subjects here. Instead of entering all the 6 subjects as subject 1, subject 2, subject 3, subject 4 like this, simply enter subject alone and use an array here. After the subject, your class is done. Then the same subjects only is going to appear under your exam cell, right? So you don't need to repeat it. Here also same student ID is there, same exam semester is there. Only thing I'm going to get new here will be result. Again, under the results, I can do two things. Under the results, I'm going to get the overall result as well as the individual results. Let's say overall, simply you can put pass. Then I have individual, right? When it comes to the individual, each individual subject you can use as a one embedded document, so that I can keep everything in a single document. All the values are embedded to each other. That is the reason we can call this as an embedded data modeling. Now the question is how I can justify this as a good data model. Instead of going for multiple collections, I'll go for a single collection. Within the single collection, all the data together, I'm going to keep it in a single document by utilizing all the data types that are present within the MongoDB. I will embed everything into a single document. That is the reason I call this as an embedded document. The main advantage of this particular system will be, suppose I want to get the information about the student ID 101. In RDBMS, I have to join these three tables, then only I can get it. But when it comes to your MongoDB, first thing will be, everything will be queried with a single query itself. Or single extraction will give you the complete data. If I say 101, it will give me the details about the administration, it will give me the details about the class, it also give me the details about the exam. If I want to update, the same thing. I don't need to update three different tables. Suppose if I want to update the semester details of this 101, I want to update his phone number and I also want to update these two only. Semester I need to update in the two different tables and phone number I have to update in one table. All the three tables I need to update individually. But when it comes to the MongoDB, no need. Single query, fire a query, get the details and update it with a single query itself. I just simply use db.your_class.update. Then I'll say that student ID 101, comma, $set. Under the set, whatever I want to update, I can update it. So all the read and write operations are easy and efficient. That's the first thing. Second, this is going to be the most important thing. We can support atomic operations at a document level. So what are the storage engines? The storage engines are the ones which can say that we have two types of storage engines, that is mmap v1. Another one is going to be your wired type. When it comes to the mmap v1, in mmap v1, we have the concurrency level at the collection level. Concurrency is available only at a collection level. What is the meaning of concurrency and a collection level? Let's say that I have a collection which is having 100 documents. If I am modifying any one of the document, entire collection is going to be locked. You cannot do any write operation to any other document that is present in the same collection. You have 100 documents in the collection. Out of that, you are actually updating the first document. Still 99 more documents are available. The moment I'm updating the first document, all the 100 documents are locked. Since all the 100 documents are locked, I cannot do any write operation to any other document that is present in the same collection. But when it comes to the White Tiger has a little update. That is, White Tiger offers you the level of concurrency at document level. Only the document that you would like to update, the remaining documents will be available for your data update. What is the usage of this now? Since I'm locking the entire document of that particular record, that is say 101, the entire 101 I have locked here. Because of that particular reason, since no other modifications are happening on this particular record, I can maintain the atomicity. What is atomicity? Either all the changes will be committed or none of the changes will be committed. But it should be happen at the entire document level. That document level atomic operations can be do when it comes to your embedded data modeling. Now I'll go with the second one. Second method is nothing but linked database modeling. So when it comes to the reference or linked database modeling, the name itself is telling this is nothing but a normalized model. It is nothing but a normalized model. Don't keep the data into a single table, keep it into the multiple table. Avoid the redundancy. When it comes to the MongoDB also, we are going to use the reference model, that is nothing but your normalized model. The reason behind using the normalized model is again the data redundancy. The normalized model is nothing but don't keep the data into a single document, keep it into the multiple documents. That is, keep it in more than one document, refer the numbers. Reference model is nothing but simply you can say that it is nothing but the normalized model. In SQL, you are going to use the joins. Here, you are going to use the linked documents to join between the collections. In the first day, I said I'm going to give you one contradictory statement when I'm going to explain about your database modeling. That contradictory statement is MongoDB support no joins. That is, there won't be any joins in MongoDB. But just now I informed that the joins work can be done with a different method, and that different method is called the refer method. Will MongoDB have joins or not? Based on the definitions, no. But the joins work will be done in MongoDB by using the reference modelings. The most common thing will be we use the reference ID to refer one document with another document. What is the unique thing which is present in the document? We said that underscore ID is the one which uniquely identifies your document. So the underscore ID of the one document will be referred as the another document. But it is not mandatory. It is not mandatory that you should use only an underscore ID. But the right way, the most standard way that we follow when it comes to the real time is nothing but we use the underscore ID. But again, what will be the percentage of utilization when it comes to the embedded modeling as well as the reference modeling is the embedded modeling will be 70%, the reference model is going to be only 30%. 90% of the cases we generally go with the embedded model only because it is easy to read and it is easy to update. But the disadvantages of your embedded data modeling will be size. Everything I'm keeping in one document, right? So what will happen now? The size of the document will go beyond 16 MB or not? Before everything is splitted. Now I'm keeping everything into a single document. The size of the document may go beyond 16 MB and I should end up with going with the ZFS. Second, again, it is also related to the size only, but in a slightly different way. Let's say I'm using array here. This particular person, there is a student ID called 101. He failed in the main exam. All the 6 subjects he got failed. He appeared for one more time, supplementary. But this time he passed 2, remaining 4 got failed. Again, he attended one more time, then he cleared. But all this comes under results only, right? Under the results, I should add one more field called year. For the each year, what are the subjects he appeared? What is the result of that particular exam? Everything I'm going to keep it as the embedded documents in the array. So what is the problem now? As long as I have embedded documents, there will be high chance that in future there should be a data growth. A student may go for at least 3 supplementaries maximum. Then 3 means totally 18 elements are required for 6 subjects. So I said that for the results, I simply mentioned that there should be 18 bytes of the data available. Few documents may use it, few documents may not use it. When the size of the document is keep growing, I cannot meet the criteria of 16 MB. When the 16 MB criteria is not meeting, GridFS is come to the picture and I'm not able to do the data modeling. So the main disadvantage of your embedded data modeling is going to be size. The second thing will be chance for high redundancy. What is that redundancy and how it will be? We are going to discuss. So why data modeling? We already discussed about it. Just go through the slides. Second, data modeling approaches. In RDBMS, we have 2 approaches, right? Top-down approach as well as the bottom-up approach. This comes under the SDLC, software development lifecycle. Nothing much to discuss about it. This is the another one which I have not mentioned there, but it should not have 5 instead. I'm talking about the perspectives of data modeling or types of the data modeling in general. If you consider whatever the data modeling I'm showing there, if you consider your data modeling as a pyramid, then how it's going to be is this pyramid, let's say that have 3 layers. This is layer 1, this is layer 2, this is layer 2. The bottommost layer is nothing but your conceptual data modeling. The name itself suggesting it's all about the concept. Whenever we want to release a new model or whenever I want to release a new product, let's say a new cab service want to launch in India. The new service, if I want to launch it, what are the basic stuff I need to do? What are the analysis I need to do? Before I meet any of the developer to create an app for this particular one, so what are the basic requirements for me? How exactly I would like to implement this? All high-level business logic or all high-level business algorithms are going to be part of your conceptual data modeling. Once the conceptual data modeling is done, then we go to the second level. The second level of modeling is nothing but logical data modeling. So logical data modeling is the place where we actually discuss about entering the relation, which software we need, which database we need, which scripting language we need, what are the various table structures we have, how to get the relation between these tables. Every piece of information about the ones that we have talked in your conceptual data modeling will be part of your logical data modeling. Last but not the least, that is nothing but your physical data modeling. Physical data modeling is the one where we actually enter our data. That is, we start supplying the data based on your algorithms, based on your end user mindset. You're going to design your data and you're going to see the simulated results first, then you're going to see the actual results. These are the 3 basic parts of any database modeling. So this is common for every database. First, we sit with your BA or we sit with your business end user and discuss about what needs to be done. Once we discussed about it, technically we discussed internally again within the team and decide which software we need as well as which database we need. Then we talk about the last one. You have the logics with you, you have the data with you, you have your physical structure with you. Why can't you start loading the data into the application? That is nothing but your physical data modeling. The same one, they have enhanced a little here. So the conceptual, logical, physical, both these 3 are same. They extended this a little into the ER model as well as the dimensional modeling. These are the extensions only, but these are not part of your data modeling. That's the reason I have not mentioned there. This we discussed in the first class. That is, in the introduction, we assumed that, we said that there is an evolution of the databases. The evolution of the databases happened with a flat file, then it went to the object, then it went to the relational, then it went to the hierarchical, like this. The star schema which I have shown here is nothing but it more belongs to the data stage guys. They will do this, all this drag and drop and everything. So that's the thing we have there. Star schema. Star schema is nothing but I have one fact table and the remaining are the dimension tables. The fact table is always be at the center and the dimension tables will be always connect to each other with the help of our modeling. Star schema, this is what I said. Here is the fact table around which I will be having the dimension tables. We always write the relationship between them. Hierarchy schema is all about you'll be having your grandfather, father, and you. So the legacy will be continued. Relational database. So when it comes to relational database, the data will be always distributed whenever we need the requirement. All we need to do is we write a query and we'll make sure that you're going to get the updated data. Object relational data modeling, this is extension to your Java or something. It is all talk about why can't I store the data as an object and draw the relationship between them. It is booming now, so most of the people started using it, but it requires sound knowledge in the your programming languages. Now, MongoDB and database modeling, all the top layer is going to be your input sources, all the bottommost layer is the place where you store your data. In between that, you perform a database model and you say how to store the data, and you have to write a queries to store it. And you have to maintain the entire cluster. I want to maintain the performance, adding the users, blah blah blah, and all that can be done under the management. Maintaining the security, 3 internal methods and 2 external methods be done under the security. So since this the particular diagram we have already discussed, I'm not going in detail with this. MongoDB has a flexible schema, flexible or dynamic, both of them same. MongoDB collection does not enforce document structure, that is, you don't need to maintain the same structure throughout your collection. This flexibility facilitates the mapping of the documents to an entity or an object. Each document can match the data fields of the represented entity, even if the data has substantial variation. So this also we discussed under the reference model. You can match with anything. However, the documents in the collection have the similar structure. Since we have the facility, we don't want to simply random data. We don't want to store it in a single one. The key challenges in the data modeling is balancing the needs of the application, the performance characteristics of the database engine, and the data retrieval patterns. While designing database models, always consider the application's usage of data and data's inherent structure. The next thing is going to be consideration for data modeling in MongoDB. Document structure, you should know your structure, then only you can go for the modeling. Atomicity of the write operations. If you have more atomicity of the write operation, you'll go with the embedded modeling. If you don't have atomicity operations, I'll go with the reference model. Growth. If the document is going to be growing in the future and if you are sure that it is going more than 16 MB, irrespective of whatever the case it will be, always go ahead with the linked model, that is our reference model. If it is not the case, if there is no scope for future growth, or even if it is a growth, it will not go beyond 16 MB of the size. When it comes to the data use and performance, it's all about what kind of data it is using. Is it a read performance you're looking for or a write performance you're looking for? For an example, if you're looking for our health insurance applications, like let's say I have an insurance with MetLife. My MetLife application, I don't enter much data there. But let's say that what is the status of my claim? If I enter my claim number, I should get the details regarding it. I'm looking for more read performance here. Suppose wherever the case where I'm inserting more data, continuously I'm inserting the data. I don't read anything, but I'll insert the data like a hell. In that case, I need to have a write performance. You should know what kind of data you're using and what is the performance you're expecting. That is called your data use and performance. The 4 will be repeat now. Now, this is the document structure we talked about. One is linked and an embedded model. This is nothing but that there are 2 models that are available. So I said there are 4 things that will repeat. That is atomicity, document growth. When it comes to the MongoDB database modeling, as I said, only 2 options. What are them? Embedded data modeling, reference data modeling. Embedding means all the data we're going to keep it in a single record. Reference means more than one link I'm going to use. I'm going to combine more than one. This is the perfect example for embedded. So just like how I explained this class, so that is administration class and result. Here I'm going with a blog. Let's say I have a blog. Whatever the blog I have, all the posts that I have I keep it in one table, that is post. That is what is the ID, what is the title and all. Whoever comments on it, the user ID and comment will comes under the comment section. Whatever the tags I put, the tags will be under the tags. So instead of keeping 4 different tables here, when it comes to the MongoDB, I can simply use whatever the biggest color is there, that is going to be the embedding. I'll keep everything in a single document. I'll show you an example. When it comes to the reference model, it's slightly different. Means, let's say I have a user document here. I have the contact document, access document. Both of them need the user information. So what I do is, if I go for the embedded data modeling, whatever you are seeing here, 1, 2, 3, 4, that is the ID, username, login time, department. These 4 key value pairs, I have to paste it here, I have to paste it here. But within a collection, for 2 documents, I'm repeating the same data. So what I'm doing now here is, whatever the object ID I have here, underscore ID I have here, right? The underscore ID of the user will be call it as user ID. The moment you call the user ID of object ID 1, wherever object ID 1 comes under the user ID field, these 4 values will be resolved there. But if I want to go with the reference modeling, at least 2 queries I need to fire. One query to represent what is called my document, second query to query the actual data. The reason here will be, when it comes to the embedded data modeling, whichever you want to refer, that reference itself you are going to give it under your collection name. So all the documents and all the key value pairs that is part of your newly referred document will be part of the old document. Whatever you are looking on the screen, these are the various operational and data models that are part of your MongoDB database modeling. Again, the same stuff I'm going to repeat. You should know what is your data lifecycle. You should know atomicity. You are looking for the atomicity or not. If looking for the atomicity, go for the embedded. Else, go with the reference. A large number of collections, sharding, document growth, and indexes. GridFS. If there is any file which is going beyond 16 MB, I'll go with the GridFS. What actually GridFS will do? Whatever the file which is beyond 16 MB, it will split into 2 files. One is, whatever the files it is going to keep there is nothing but, you can call them as the chunks. Chunks is nothing but 16 MB each document. If it is more than 16 MB, then I'm going to use the GridFS. What GridFS will do? GridFS will break this entire 16 MB into equal number of 256 KB files. Each 256 KB files will be called it as chunks. MongoDB will break your entire data into equal number of chunks. Each chunk size is of 256 KB. Now, so the data will be stored, but in which file, which data stored, you need to know, right? That is called metadata, right? So what actually GridFS will do? GridFS will break the file into equal number of chunks. Each chunk size will be going to be 256 KB. It is going to have 2 collections. One collection is for actual data and the another collection is for the metadata. So GridFS is used 2 collections to store the files. One collection stores the file chunks, that is data, and another collection stores what data is storing under which chunk, that is metadata. So whenever the user asks for your data, it will automatically collect the data and send back to the user. So GridFS is the one which will break the file into equal number of chunks of 256 KB each and maintain 2 different collections, one for storing the file and another is for storing the metadata. And whenever the user is asked, it will actually combine the data and send back to the users based on your requirement. For storing the movies, for storing any file which is more than 16 MB, GridFS is the right choice. Apart from either database modeling, or apart from your embedded model or reference model, there are some more examples and patterns available in MongoDB. Those are model relationship between the documents, model tree structures, model specific application context. So the model relationship between the documents is nothing but what kind of model generally exists between the documents. In those cases, what kind of method I have to use? That is, I have a one-to-one relationship. That is, so this is the one-to-one relationship. I have some user. This is the data. First thing, username, email, password. These 3 are the official information. Whatever you can see the details, these are the personal information. When it comes to the embedded data modeling and when it comes to the one-to-one relation, only there is one person related to one particular information. There is one-to-one relationship exists. In those cases, we can absolutely go ahead with the embedded document. If I go to the reference document, it is little different. The first 3 are going to be the official information. Then the last 4 is going to be the customer personal details. Why should I have both of them into the single collection? I'll keep it into 2. One collection explicitly only for the user information and another collection explicitly for the details. How I'm linking these two? Whatever the underscore ID I have here for under the customer, that I'm calling as the customer ID here, and I'm simply giving that particular thing here. So the moment I run this particular one, it will look for your customer ID And the moment it runs for the customer ID, it is going to get these details for you. In the reference model, I don't need to go with the same document. I can simply combine all the related documents into a single document. But whereas when it comes to the reference, I cannot do that. Instead, I can go ahead with the two different things. But as long as I have one-to-one relationship exists between the entities that I'm looking for, I can go ahead with the embedded data modeling. Let's say, go with another example. The simplest example will be football is happening now, soccer is happening now. Let's say there is no leagues at all. There is no BPL, there is no EPL, nothing. There's no premium leagues at all. Only the person, each player will be comes under only the nation. The Brazil player must be under the Brazil. The Mexican player must be under the Mexican player. Only the nations are controlling it. There is no individual premier leagues at all. That case can be called it as one-to-one relation. Each player is having a relationship only with one particular entity. Let's say leagues has been introduced. Now what will happen? The person who is part of Mexico can also play for your Premier League, which is conducted by any one of your state. So what will happen there? The same person will be available at two different places. One to many. The relationship exists between me and my board. Before introduction of my leagues will be one to one, but after introduction it will be one to many. Even there is a one to many relationship exists, still MongoDB prefers you to go with the embedded document alone. Embedded documents still serve your purpose as long as you have one to many or many to one. Both of them are same. Then when to use your reference modeling then? Whenever there is many to many relationship exists between the entities, it's better to go ahead with the reference models. Otherwise, what will happen? Size of the document will be keep growing. I'll upload this particular one. You can see that there is some supporting documents. Under the supporting documents, you can have all the models. For each model, what will be the data? That is example like this. I have made it available. As long as one to relationship exists, embedded. As long as one to many exists, embedded. As long as many to many, this is actually many to many, will go with the references. But it is not mandatory. It is just the suggestion. Apart from your previous one, there are some model tree structures also. That is, some structures I can maintain. That is, with parent reference, with child reference, with array of ancestors, with materializer path, and with nested sets. You can find the right examples for this again under the docs.mongodb.com, because it's better if I explain that with some diagrams. Let me go with that. So here is the model tree structures. Let's go with that. So model tree structures with parent reference. That is, every time we'll refer a parent. That is, let's say I have a books, programming, languages and databases under that MongoDB and RDBMS. This is the structure. If I want to write a query for it, I'm going to write like this. So db.categories.creating index, you can forget. db.categories.find parent databases. That is, if I call parent.databases, what will be the output? This database is a parent. The parent has two chains. What are the two chains I have? One is MongoDB and DBM, database management. These two will come as the output. The moment I say programming as a parent, I'm going to get languages and databases as the outcome. The moment I say books, I'm going to get programs. But the moment I say MongoDB, I don't have a child for this MongoDB. It's a single parent. I don't have a child itself. So I'm going to get the null value. So what is tree structure? This tree structure is nothing but one of the way of representing your data. When it comes to the representing the data here, one of the simple way will be always represent a parent. If I come in the reverse, always represent a child. Let's say in the same case, db.categories.databases, then I won't get the output as MongoDB and DBM. This time I'll get the output of programming. So system itself telling that I'm the child of a programming. It will go up. The first one will go down. So what are the other models I have? There are some more models. Now, model tree structures with an array of ancestors. This is a bit different. The same structure I'm taking again, but the way I'm going to store the data is different here. When I go for the books, books does not have any ancestors, which does not have any parent. That is, books does not have any parents. No parent, it is going to be null. Ancestors. Ancestors are nothing but the parallel ones. There are no parallel ones for me. There is nothing but the horizontal structures. There are no horizontal structures. Let's look at the programming. It will give you the correct right example. If you go with the databases, just go with the databases. Here is the database. Database has the ancestors as books and programming. That is, before my database, I have programming and books. These are my ancestors before me, who and all there. Who is your immediate point of contact? There is nothing but who is your parent? My parent is programming. Suppose if I go for the DBM, the array of ancestors will be databases, programming, and books. All the three will come. But who is the parent then? The parent is the only one person, that is database. If I go for the DBM, ancestors are going to be all the preceders of mine, but the parent is nothing but the immediate preceder of mine. So why I'm using this? If you remember, while talking about the evolution of the databases, I mentioned that the relational model, that is the hierarchical database, got disadvantage that if I want to get the relationship between the topmost person to the bottommost person of my tree, it is difficult to extract. I don't have a proper structure there. But when it comes to the MongoDB, and if I go with the model tree structure with the array of the ancestors, irrespective of whichever the location you are, whichever the part of the branch you are, if you want to see all your preceders, immediately you can see where it will be useful again. Especially in the organization, whenever we are going for the HR model, whenever we are going with your PHP works and all, there I want to see all my escalation list. I want to see all my previous point of contacts. I want to see the point of contacts list. I want to go with the skip levels. There and all it will be useful. So based on your requirement, MongoDB provides different paths for you, and these are the paths. So I have already explained three tree structures with parent reference, child reference, as well as the array of ancestors. You have two more things. Those are nothing but the materialized paths as well as the nested applications. Model specific application context. This, you are going to see this particular one in the indexes. That is nothing but what kind of data you are searching. That is nothing but your model specific application context. 90% of the times we'll go with the atomic operations. If you go with the atomic operations, you always go with the embedded document. The second thing will be it support the keyword search. Keyword search means if I enter a keyword, it has to go to the entire collection. It has to bring the data for you. There, embedded document will not work for you. There you need to go with the reference one. Challenges for database modeling: know your application needs, understand your performance characteristics of the storage engine. Last but not the least, know what kind of data retrieval patterns you are using. The first two are nothing but your psychological stuff. It is not reading with the MongoDB. No ACID transactions, no joins. It is not going to be a challenge at all. Paradigm shift from the traditional approach. It is also psychological one. There is no need of keeping that one here, but simply they kept it just for extending the challenges, nothing else. So the demonstration. So this is the database model in the RDBMS. Each one will be common primary key and foreign key structures. Based on that, we are going to join this. Suppose if I want to relate products and sales, both of them have a common code called product code. By using the product code, I'm going to join these two, product name, these two, customer code, these two, country code. So what is the common name between them? Based on the common name, we are going to join between them. But if I go with your embedded model, I don't need to do all this. Simply I can go for everything in a single document if I go with the embedded. Otherwise, I can go with the reference model. Embedded document, you can see that everything I keep it in a single document itself.
Thank you, Murli, for this wonderful session. I hope you guys understood the different aspects of data modeling, how it is implemented in MongoDB, the different types of data modeling, and also the challenges faced while designing a data model. So guys, if you have any queries regarding this session, please feel free to mention it in the comment section below. Till then, thank you and happy learning.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!